Good morning, everyone.
Good morning.
Yeah, morning. Yeah, new week. Okay. Yeah. Hope everyone had a great weekend. Okay. Uh, so I think, yeah. So this is new week. We continue our lecture, and I think today is the due day, right? Just again another reminder. Don't forget about that. Let me try to share my screen. I think last week we talked about, give me 1 second, let me plug in another screen. I think last week we were talking about the HTTP request and response, right? So how does a HTTP send or request or response message look like? Okay. Let me share my screen. Okay, I think you should be able to look at the slides. So let me quickly review what we have learned the last lecture, right? Content may be a bit more than previous slides. So we were talking about the HTTP protocol, right? That's a application level or layer protocol. So we talked about two different kinds of protocols, HTTP protocols, right? One is a non-persistent HTTP, another is a persistent HTTP. The main difference is that the one for the non-persistent HTTP, when you open the TCP connection, generally speaking, you send one object and file for one time, right? After that, you need to close the connection. But for the persistent HTTP, you should remain the connections and you can send and receive the multiple HTTP requests and responses, right? That's the main difference. And after that, we talk about what are included in the HTTP request message, right? We have the request line for different operations or the commands, right? Get, post, delete, and other comments, right? And also we have the headlines here, including the host and other information for the language encoding, right? But these are not necessary, right? For a simple HTTP request message, you only need to have the first request line and second headline, right? That should be fine, as we showed in the demo. Okay, and after that, another space line to end the request. Okay, so this is the general format for the HTTP request message. And also we were talking about what kind of the request message or operations you can put in the request line, right? You can do the get, you can do put, you can do post, you can do delete, right? Different operators here. Okay, so that's a request message, right? I think at the end of the last lecture, we also talked about the response message very quickly, okay, but very quickly. So let's try to review that response message. So similarly, the first line is some meta information, right, to give you some idea what is the response look like. So first line is what kind of the HTTP version, right? Similar to request, you have to specify the HTTP, for example, /1.1, the HTTP version, and also a status code and a status phrase. So what does status code mean? So I will show another slide to say that. So for this response message, it's okay, right? 200 and okay means your request has been well received and the HTTP server has responded to you with data, okay? And after that, similarly, it's, there are headlines. You have the date, you have the server name, you have the other information, right? And space line, okay? Here, let me try to change a laser. So here is a space line, right? After that, the HTTP server will give you the data, right? The HTML files, right? The file will be displayed in the browser, right? So I can do another demonstration again after we finish the HTTP response message here. Okay, so this is a general format, and this is an example of HTTP response message, right? Similarly, we have the information headlines and the other information here, but the last line is the data itself, right? This is a very simple HTML file, right? Just a one line to show in the web page that welcome to the home page, right? Yeah, that's it for the response message format, okay? And what do I mean for the response status code? I believe most of you have experienced that 404 not found, right? So when you try to access some web page and you can easily find some web page has been moved, right? Or removed or deleted. So the web page will show you 404 not found, right? So 404 not found is a commonly seen when you browse in the internet, okay? And if the request, just as mentioned, if the request has been well received and has been succeed, the response will include status code 200 and okay. That means the request succeed and the request object later in the message, right? And 301 means the web page has been moved permanently, but it will give you a new location specified later in this message. So you can use the moved URL to access the new location. Okay, 40 is a bad request. The request message is not understood by the server. Okay, so that's the problem of your request, not the problem of that web page, because your request has not been well understood. Okay, that means your message written in the HTTP request has some problem, right? You have to debug or see where is the problem. And for the 404 not found means that your request has been received, but the server cannot identify the HTML file, right? That means the file has been deleted or moved to some place, but there is no hint where it has been moved, maybe just deleted, right? So that's why for not found is showed. Okay. Finally, the 505 HTTP version not supported. So if you request the HTTP 1.0 or .9, right? So those version may not be supported well by the HTTP server. Okay. So that's a commonly see status code and problem or reason. Okay, you can easily find those things happening in the internet. Okay, so that's a thing I tried last week, I think. So we can do this again, I think, because last week we haven't talked about the response, but let's do this again. So if I open a terminal, right? If I open a terminal, and as I mentioned, I have the Telnet software. Maybe this time let's try, let's first try the link given by the slides. Okay, so let's try this one first. Maybe I need to. Okay, let's try this one first. And it has been connected to the server, okay? And I use the get command to get command to access this web HTML file, right? And I give the HTTP version and this is the host name. Okay, after that, I give a space line, right? Space line means that, okay, my request has been done. And this is a response. See, this is a response. So the first line is a HTTP version and the 200 OK. That means we have successfully, the request has been successfully received, right? And the web page can be returned to you. And after that, it's some information, right, for the headlines. After that, it's HTML content. Okay, so those are HTML content. So if I use a browser to address this URL, so you can see that the web page has been visualized or displayed by the browser. Okay, and finally the connection has been closed. So let's try the web page. Okay, to see what is the web page look like. Let me share my browser. So this is the Safari browser, right? The IMAC default browser. So if I use, this is a host, right? But after the host, I need to give the path, right? After the host. So you can see that this is the web page, right, of our textbook. And because we use Telnet to successfully send the request and receive the response, right? So that means this web page can be get correctly. Okay, so if you are using the browser, you can see the previously HTML files or content has been visualized or displayed by this browser, right? So if you get the, maybe if you have some third-party software, you can analyze and get the HTML code here as well, okay? So that's one quick demonstration. I can also demonstrate maybe using our own server. Let's try, okay? Maybe eecs.wsu.edu. Okay, we successfully established the connection. Okay, and then later we want to do get. Okay, maybe my personal web page. Example.html. Okay, oops. Oh, it says that, let me try that again. Get. That means the document has been moved. This is let me see. There should be some problem here. That's not correct. This is a bad request, right? I believe this one should be right. Let me try using the browser directory. Okay. Yeah, I think that's the right request, but because the file has been moved permanently and it give you the another address. Oh, that's a good hint. Yeah. So, right. That means it direct me to HTTPS. Yes. I, so hold on one second. I think I correctly, give me 1 second. Server name, not no. Okay. So I think yeah, it direct me to HTTPS server. It should be. But last time when I tried this, it's also moved me to another link, but it's not like this way. It is wecswsu.edu slash this link. And after that, you should be able to see this web page. Okay. So maybe some of you can also try. But I think it should be the same, right? Yes. Try and move me to the HTTPS server. I think, yeah. But for the our this link, it's not the. This is the HTTP, right? This is not the HTTPS, so that's why we can directly access this. Okay, so maybe I should try some link without HTTPS, just HTTP. But our server has been establishing the HTTPS server. So anyway, yeah, I can try to find another HTTP server later and do another, yeah, demonstration. But I think this demonstration have give you some idea about how we access the UMass, right? UMass server and HTTP server. So that should be fine to give you some idea. Okay, we get exactly the same same content shown here. I'm not sure if our university have any HTTP server here, do not direct us to HTTPS, but let me try to find. Our ECS server seems to be a HTTPS server, okay? Because the HTTPS server has more security level, higher security level, right? HTTP is a less secured server. Anyway, yeah. Okay, so that's the thing we showed for the send and the request by the HTTP server and the client. Okay, and after that, let's see some cookie things here. Okay, still remember we say that the HTTP get response or request response interaction is a stateless, right? Still remember it's stateless because we don't want to keep track of states of HTTP message, right? But sometimes it's needed, right? We need to have some tracking information. So, for example, if you log into your Amazon account, right, you purchase something, every time if you put some items into your cart, right, you want to see what things or what items have been already added into your cart next time you access the website, right? So that means the website or the Amazon server, HTTP server, record some of the information, right? Have you think about this thing, right? So why the server knows that's you and keep the items you have already added in the cart and show those items to you again, right? When you access the web page again. So that's thing we called cookies, right? So the HTTP server clients agree to use cookies to record some information that's not for the next time or for the following web request and response, that they can provide you some historical information. That's a general idea why we use cookies. So here is a quick note, no notation of multiple steps exchanges of HTTP message to complete the web transactions. Because no need for client server to track state of multiple state in exchange, right? All HTTP requests are independent of each other, right? And no need for client server to recover from a partially completed but never completely completed transaction. Okay, that means if your transaction is not completely completed, then you don't need to recover it, right? So if you look at the right-hand side figure, so if we do multi-stage, right, interaction. So first we log the data and we record X, right? And then we update X by X prime, and then we update X with the X prime prime. Finally, we unlock X, okay? So if some bad thing happens, if the network connection clients crash as a T prime, right? So at this point, then that means this multi-stage transaction hasn't been completed, right? What will happen, right? That's a question, okay? If you don't have any information to record this, then some bad thing will happen, right? So if we have the stateful protocols, the client could make two changes to X or none at all. Okay, if we have the stateful protocol. But if we don't have that, the thing would be you only update X for one time, right? It's not a complete transaction. It's still in the intermediate state, right? It's not complete, right? We hope that it's happened or not. We update or not at all. If you don't have this stateful protocol, then some not, you don't want to just leave some intermediate state in the server, right? You want to totally update or just leave that as it is, right? So that means we need to have some protocols like cookies to help us make a track of the privacy operations or transaction, okay? So the website and the client browser use cookies to maintain some state between the transactions. Okay, there are four main components of the cookies. So cookie header line of HTTP response message. So first you have to let the request and the response message to know, right? What are the HTTP clients, right? You have to give the server some information. Who are you, right? So no matter your address or some other information to help the server side to recognize or record that is you, right? After that, the cookie file has been kept on the user's host managed by user's browsers. And the backend database at the website can also maintain this information. This is like a key, right? So you keep a key, and the server database also keeps some information of the key. When you access that server again, then the two keys pair together, right? Then, okay, you can recover some previous information, right? So if we look at the quick example, so here Susan uses browser on laptop, visits specific e-commerce site, for example, Amazon, right? For first time, when initiate HTTP request arrive at site, the site creates the unique ID as known as a cookie, right? Unique ID and entry in backend database for this ID. So they just record this information for Susan, right? Using the same laptop, visit this site, right? And subsequently, the HTTP request from Susan to this site will contain cookies with this ID value, allowing site to identify Susan, right? So this is like an ID, right? You just, when you first time send a request, HTTP request to some server, the server just keep your identity, right? And the next time when you access this server, server recognize you and provide the previous information to you. Okay, let's see diagram that showing how client side and a server side using the cookies to send and receive the requests and the responses. Okay, so first, client use the HTTP request message. For example, let's say the server side is Amazon, right? Amazon server create ID 1678 for this user, right? If this is, for example, Susan, right? Susan uses her laptop, okay? And create this unique ID and put this unique ID into a backend database, right? So that means Amazon has to have a very large database to recognize a lot of users, right? And after that, it will send the ID or cookie Amazon server created, right, back to Susan, right, back to the client. And the client will know that, okay, the Amazon, my cookie, my ID is 1678, but different server, different, for example, e-commerce company have different cookie database, right? So for example, the Amazon has provided a 1678, eBay could provide another number, right? And your browser will save this information for you, right? And after that, if you want to access Amazon again, server again, the HTTP request message will take this saved cookie 1678 with the message again to the server, okay? And the server will identify that, okay, that's Susan, right? Because you provide the 1678, it will match Amazon's backend database, okay? And it will recognize, okay, it's Susan. And then it will give you some of your previous saved information you want to save in the server, right? What kind of the information you want to save, we can see later. But after 1 week later, you still want to see that information, okay? And you send that HTTP request message with cookie again, and the database still save your information and give you your historic information, right? So that's how server and client use cookie to communicate with each other and recognize who is who, right? And I mentioned historical information. What is this? What kind of the thing you want to track? So for example, we want to do the shopping carts, as I mentioned, right? Everyone is using Amazon. You can realize that you put some items in the cart, but 1 week or 2 weeks later, if you log into your account, you can still see that the item has been there, right? Because the server recognize you, right? And also, and that's may not need you to log into your account, because if you log into your account, then that item could be recognized in your account. But even if you don't log into your account, that items could be also still be kept in the cart, because that information is based on your cookies, not based on your login account, right? It's just based on the browser cookie. Okay, and some recommendations, right? What kind of items, what kind of information, news you want to read, and you give the information to the server, and the server can recommend to you, right? And also authorization and the user session status, such as web email, some historical information, right? And the challenge is that how to keep the state. The protocol endpoints need to maintain the state at the send or receive over multiple transactions. Okay, and they have to have a database. Browser have to have a small database to keep track of yourselves accessed websites. But the server side need to keep a large amount of the cookie information, right, from different user, from different IP address, from different machines, right? And the HTTP message needs to contain the cookie information and carry out the state, right? So that's a general idea, but there will also raise some privacy problem, right? So the site will keep some of your privacy or some of your information, right? And the cookie permits the site to learn a lot about you, right? You give the permission that to record some of my operation or HTTP request transactions, right? So I think maybe you have noticed that if you log on, if you access some web page, sometimes it will give you a pop-up window, say that do you allow us to use the cookie? You can say accept or decline, right? So if you say accept, that means you give the site the permission to use the cookies, right, to learn about you, to keep track of your historical information, right? What you have been accessed and what you have been browsed, some information here, right? So pay attention to that. So if you have if you're cautious about your privacy or something, maybe you don't want to give the cookies permission, but for personal speaking, I'm fine, right? I just browse some general website. If you keep track of my login information or what I have browsed, I'm fine, right? You can give me better recommendation. That's what I want to see here, right? And sometimes there is a third-party cookies, right? Tracking cookies allow common identity, right? So as I mentioned, for different websites, you have the different cookie number identity, right? But if you can use a third-party software or cookies, they can keep tracking of all your browser information and make maybe better recommendation, right? Across Amazon, eBay or something, right? So you can allow that, provide better service, but that also expose your privacy to the third party software, right? So that's the idea of how we use HTTP cookies to keep track of the your historical information or state of the HTTP requests and the response. Any question here before we go into next idea? There is a question, does that mean your shopping cart could look different across different browsers on the same computer? That's a good question. I think for the different browsers, the different browsers should have the different cookie database, right? If you are using the Firefox and the Chrome, if you, just as we mentioned here, you can have a third-party cookie system to manage a different browser and different website. But I think in default, the cookie information in Chrome may not be shared with Firefox or other web browser. So maybe you can notice that sometimes you put items in the Amazon cart using the Chrome, but you open the Safari browser, that information may be disappeared, right? So that means if you want to different browsers or different website want to share the same cookies, you need to have the third-party persistent cookies, right? Tracking all the cookies across different browsers, across different websites, okay? So that's the idea for this basic concept, HTTP cookies. Okay, if we don't have question, let's continue. Okay, let's continue. For the web caches, Some of you may know that uh, for computer system, we often talk about cache, right? A lot of cache. Cache could be in memory, right? In CPU, you have a L1, L2, L3 cache, right? In my research area, hyperphysical computing, you have to utilize the CPU cache smartly. That means you can reduce the data movement. What does cache mean, right? What does cache mean? Cache means that there is a space can temporarily hold some data or information for you. Then if you want to re-access the same information, it doesn't need to go to the original place, but go to your cache, right? That's the definition of cache. And a lot of places have a lot of different caches, right? So for computer system concept, the cache is a very commonly seen concept, right? A lot of places have a cache. As I mentioned, CPU has a cache, right? Storage has a cache. If you have a disk, right, you can have a disk cache. You don't need to every time go to your SSD or HDD to read the same piece of data. It has some high-speed cache area, right? Help you to reduce the overhead or time to read the same data, right? But if the data has been changed, the cache has to be updated, right? So what about web caches? Similarly, right? Similarly, I think some of you may think about this idea, right? So if you want to access to the same data every time for the same data, you don't need to every time go to the server, right? You can have some space to temporarily save the data for you. And if client wants to get the data, they don't need to go to the original server. They just send a request to the proxy server or cache server, right? And it will give you better performance or less time, right, overhead. So specifically speaking here, so user configs browser to point a web cache. Browser send all HTTP requests to cache if object is in the cache, right? The cache return object to client. That means you don't need to go to the original server. Else, that means the object is not in the cache. The cache requests object from original server. Cache is receive object, then return the object to client. That's something like a intermediate server or maybe if you think about that's a person, right? That's a person between two people, right? If I have already got the information, you don't need to ask the original person, right? But if I don't know, I just ask, hey, what is the information? And then I will pass the updated information to you, right? Next time, if some other one ask me, the information has not been updated, then I can directly tell you, right? That's a general scheme. It's not difficult to understand here. Okay, so if you send HTTP request, generally speaking, if the proxy server doesn't hold this information, then it will go to send the HTTP request to the original server and get the response, send the response back to the client. But if you have already, the proxy server has already got the HTTP information, right, or the message, then it just directly gives that response to you. Okay, that's the web cache. I think someone is discussing the midterm. Okay. Also, I'm confused about how many exams we will have. On side, I say there will be one midterm and one exam, but the lower below in grading there will be 3. Let me try to clarify that. There are only 2 exams, okay? One midterm and one final exam. So if there are 3 exams, that would be a typo. I will update that. We only have 2 exams, one midterm and one final exam, okay? So for web caches, that's concept I just talked about. So the web cache acts as both client and the server. Okay, so if the HTTP message or data has been already located in the proxy servers, then the proxy server will act as a server, right? So if the client requests the HTTP message, then the proxy server just act as a server side, right? Give the response to you. But if the content has not been updated, has not been located in the cache server, it will act as a client, right? To send a request to the original server and receive the response. After that, you will act as a server again, okay? So you can think about the proxy server has a two functions, right? As the server side, as the client side, okay? So the typical cache or web caches, a proxy server has been established by ISP, university, company, residential ISP, right? Because university, so we will do a simple calculation in the next few slides. You will notice that you have to have the web caches. Otherwise, the latency would be very high if all users would send the request to the original server, okay? If you establish a cache, that means, for example, every day people are accessing wsu.edu, right? That website, and for example, maybe not wsu.edu, that's a local server. For example, let's say some larger server, google.com. Okay, let's say that. And some local ISP or Google could provide some cache system in the region, right? So you don't every time go to the original server, right? The cache system could be work as an intermediate server, right, for you. Then it will give you some better performance. So we will do a simple calculation to see how we can improve the performance using the cache system, okay? So why we use the web caching? As I mentioned, it will reduce the response time for the client request, right? The cache is closer to client, right? It's regional or local, right? And also it can reduce traffic on institutions access link. Of course, you don't need to send all the requests all side, right? Some request has been solved locally, right? So the main traffic in the institution's access link could be relieved, right? And the internet is dense with caches, enables poor content providers to more effective deliver content, right? You add more local things and to make the main poor deliver content more effective, right? So this is the purpose why we have to have the web caching. Okay, let's see a simple scenario or calculation why we want to have a caching. So let's see the access link rate is about 1.5 megabits per second, okay? So let's say this part is 1.5 megabits per second access link from public to public internet to the local institution internet network. Okay, let's assume this number is not very high, right? But actually, I believe it's much higher than this number. But just for the demonstration purpose, let's assume a small number here, okay? 1.5 megabit per second access link. And every time if you want to access the web object, the size is the 100K bits. And okay, the RTT from institutional router to server is 2 seconds. Still remember the RTT, you send the one message and get that response back, right? That's a 2 seconds, let's assume this, okay? And the average request rate is about 15 seconds per request. Every 15 seconds, you will, one user, not you, one user would send one request, okay? So we can see the average data rate sent is about 15 second times 100K bits. So that would be 1.5 megabit per second. Okay, we can calculate, oh, sorry, here notice every 15 second per message is every second 15 requests. Sorry about that, yeah, I'm wrong. Yeah, so it should be 15 per second. That means every second that would be 15 requests has been sent, okay? So every second 15 message, every message would be 100K bits. So totally 100K times 15, right? So 1.5 megabit per second, the average data rate. So if we consider our access link, that would be 1.5 megabits per second, right? So you have 1.5 megabits per second. That should be a 1.5 divided by 1.54, right? To be accurate. So that would be over 97%. Okay, but for the LAN utilization, because that's an internal internet, so we can assume that we use a 1 gigabits LAN, right? So Ethernet or something here, that could be high, right? But the outside access link could be low, right? That's our assumption. So you can see that the LAN utilization is very low, right? Because we only use 15 megabits divided by 1 gigabits, right? It's about lower than 1%. But the access link utilization would be very high because there are a lot of users trying to access the public server, right? You don't have any cache here, right? Every user has to go to the public internet server, right? So that means the from the institution network to public internet, this would be a bottleneck because 97 utilization, right? 97% of the utilization. You still remember if we, this is the figure we showed before, right? So if you have a very high traffic intensity, right? 97 is very high, almost close to 100%. That means the delay would be extremely high, right? So you remember this curve, right, would be extremely high. So let's say access link delay, let's assume it could be minutes, right? Compared to the RTT, right, 2 seconds, that could be minutes. And plus some microsecond LAN delay, because LAN is only about lower than 1% utilization. So let's say the main bottleneck would be the access link delay, right? So if you add all the delay together, but we only care about where is the bottleneck. So the bottleneck is the access link delay. The main reason is the utilization is too high. Okay, this is our conclusion. So how can we solve this problem? Maybe we buy a faster access link. We improve the 1.4 megabits access link to 150 megabits, right? Then you can reduce the percentage, and then you can reduce the from minutes to microsecond, right? Because you reduce the utilization from 97% to 0.97, right? Then you will have a good performance here. But if you upgrade your access link by 100 times, that would be a huge expense, right? You have to do a lot of upgrade, you pay a lot of money, okay? Then what is the solution? So the solution is just what we discussed. Let's use caching. Okay, let's use a caching. If we have a cache web server here or proxy server here, and sometimes if the content from the public internet has been already cached in this server, that means some user do not need to go to the public internet server, right? That will relieve the access links utilization here. So let's say some and also this is cheap, right? But what about the performance? Is the performance good or not? Let's see a quick calculation here. If we suppose that 40 requests has been satisfied at cache, that means okay, 40% of the data request has been responded by the local web caches, right? You don't need to go to the internet, public internet server, okay? But the 60 request has to go to the original, okay? And then we can do a simple calculation. So 90% of the delay from original server, but the 40% of the delay satisfying at cache, okay? And then we can calculate that the data rate to browse over the access link, because we only have 90%, right? Of the requests sent or go through the access link, then 60% times 1.5 megabits per second. That would be 0.9 megabits per second divided by 1.54. It would be lower than 60%. Okay, so if it would be lower than 60%, then the delay could be good, could be the microsecond, okay, times 40%. Sorry, yeah, sorry, yeah. So if 60 is not satisfied, right? 60 is not satisfied, so the delay would be some seconds. Sorry about that. Yeah, about some seconds. But 40% that satisfies the caching. So you don't need to pay some delay here, right? So you can see that generally or overall that the delay would be only about some seconds, right? It would be much good than the original case. Okay, and also it would be much cheaper than you upgrade the access link here. Okay, so that's the general idea. That we can review the calculation here, but I just want to give you a quick end here, conclusion here. So if you use access caching server here based on the probability, right? So, but if you assume that almost 90% of the requests cannot be using the cache, then the problem is still there. So you have to guarantee that high accuracy or a high probability would be happen here for the cache, right? For the caching server. Okay, if you, for example, have a 40%, then the problem been solved very well. Okay. Sorry, I think I have some extra time already. And let's done here for today. So any question before we end today's lecture? I think one more question in the chat. Oh, still the midterm. Yes, it would be near the break. Okay, so we can discuss if it's before the break or after the break. But generally speaking, in my previous class, students prefer to do that before the break. But some students may prefer to have a review or do some exercise during the break. So let's say we will discuss that. But yeah, we can do before the break if you want. For the homework question, let's discuss in the email. So I can also CC the TA for answering your question, okay? Any question about the class? Okay, so if no questions, thank you everyone. See you on Wednesday. So for the homework question, please send me an email. Okay, I will discuss the question with you also CCTA so that everyone can on the same page. He can be also aware how to grade your assignment. Okay. So thank you so much, everyone. Let's see you on Wednesday. Have a good day.